I want to find the domain and range of these three graphs. Now, these are relations. Remember, a relation is a set of ordered pairs. Now, remember you talked about last semester about functions and relations. Most of what we do in here will be functions. We haven't talked about functions yet, but we will do a lot of stuff with functions. You'll be graphing functions. Do you remember from based on what we talked last semester, is this a function? Is this relation a function? Well, first of all, you got to remember what a function is, right? What was the definition of a function? Do you remember? For each, you got to remember this. For each x coordinate, there has to be only one y coordinate. That was the definition of a function. For each x coordinate, there can only be one y coordinate. So for each x coordinate, there can only be one y coordinate. Okay? So you may remember when you graphed a line, and I'm just going to do this. So if I were to graph this line right here, whatever it is, doesn't matter what the equation is, that's a function. This line is a function. And last semester you graphed lines, semester before that you graphed lines. So it's very good. A vertical line is not a function, so you remember that. So very good. But all the others are. All the other lines are functions. This is a function because look, for this point here, and let's say this is 4 and this is 3. Do y'all agree that's coordinates 4, 3? When x is 4, are there any other y coordinates on that line associated with 4? No. When x is 4, there's only one y coordinate. What is it? 3. When x is, whatever this x coordinate is, let's say it's 7, there's only one y coordinate. Y'all agree? And so on. So that's a function because for each x coordinate, there's only what? One y coordinate. But you also talked about the fact that you also could use what test? Vertical line test. So if you draw a vertical line throughout and it only intersects it once everywhere, then it represents a function. And the vertical line test has a relation with the definition. This vertical line test says this. You see how it intersect only once? That means for this x value, there's only how many y values? 1. For this x value, there's how many y values? 1. But when I look at that circle, if I can find it, oh, here it is. When I look at this circle right here, automatically you can use one of two things. I really need you to understand both of them. You can use a vertical line test and notice that it fails the vertical line test in an infinite number of places. So if you look at a circle, and let's say the circle's in the first quadrant. For this x value right here, whatever this is, I get this point and this point. Y'all agree? Well, for that x value, first of all, you got to agree that these x coordinates are the same because they're right over each other, right? But are the y coordinates the same? No, one's lower than the other. So for this x value, how many y values were there? 2. The definition of function says that for each x coordinate, that can only be how many? 1. So it fails the vertical line test. In order for it to be a function, the vertical line test must cross it everywhere. How many places? Once. All right, so that's not a function. But it's a relation, it's just not a function. Most of what we do in here will be graphing functions. We haven't done that yet, but we will. But you can still talk about domain and range. You can still talk about domain and range. All right, so let's talk about domain and range. The domain is the set of all x coordinates. Okay, domain is a set of all x coordinates. So what I was saying here, and I didn't write it down, but what I was saying was that the circle is not a function. It fails the vertical line test. So I'm just call it VLT, vertical line test. So the domain is a set of all x coordinates, right? And I'm going to ask you this. Now listen, you got to visualize this. How many x coordinates right here? You see all these x coordinates? So I'm going from, so y'all agree it starts here and then it stops where? Y'all see this? Okay, so it starts here, the set of x coordinates. So it starts here, stops there. It's not here because there's a circle anywhere in this area. No. Now here's what gets students confused. How many x coordinates are in this range right here? What some students do, they count. You would say, well, there are no numbers there. It's okay. They don't have to be numbers.
Oh, okay.
Some of you are saying. Some of you think that I'm only going to count the whole numbers. Like if this was 7 and this was 10. Some of you say, well, there's only 7, 8, 9. There's only 4. Is there? It's okay. You're using 7. You're using 8. 8 is in the domain for that one, right? Is 9 in the domain? It's in the domain. But what about 7.4? Is that a domain? What about 7.0888887?
Yep.
So how many x coordinates are in this domain right here?
Infinite.
An infinite number. You can't list them. That's why, if you recall, you use an interval. That's why you couldn't list them. Okay, so when we talk about domain and range of circles, you have to use intervals. Because it's not just whole numbers, it's not just integers, it's all these decimals, it's all the rational numbers, all the irrational numbers that are in here. For instance, the square root of 3.6. Oh, sorry, not 3.6. The square root of let's see, square root of 65. Square root of 65 is in here, isn't it? Because what's the square root of 64? 8. So and 8's in here. So in the square root of 64, a little bit to the right of that. Okay. So from that discussion, from what we just did here, and if you understand now that the domain and range, and remember the range is a set of y coordinates of the relation. When we talk about circles, it's only for circles because some other things, the domain and range is not an infinite number. But for circles, and if you understand the domain and range, you have an infinite number of x coordinates, an infinite number of y coordinates, so we can use interval notation. All right, now here's how easy it is. Go back over here to the first one. Domain, remember, is a set of x coordinates, right? Okay. So you take a rule if you need to, or take something, and you go along the x-axis like this. See, I'm going along the x-axis, and I start touching the circle when I get to what x coordinate? -3. And I stop when I get to what x coordinate? 7. Now, is -3, is this point here a point on the graph? Is that a solution? Remember, every point on the graph represents a solution. So is this point a solution? Yeah. Is that point a solution? Yeah, because it's on the graph. So use brackets. Remember brackets? Mm-hmm. So I'm going from, so this one right here, so I'm going to put it right here. I'm going to do it here. 3a, the domain. You're going from what x coordinate? See, you're not going to say -5, right? Because -5 is nowhere on this circle. X equal -5 is nowhere on this circle. So you're going from -3, so bracket -3, comma, all the way to what? 7 with a bracket. So that's your domain. The domain, you go from the smallest x coordinate on the graph to the what? Largest x coordinate on the graph. Now, just out of curiosity, look at yours. I'm just wondering how many of you can tell me the range without us discussing it. The range. Remember, you go from smallest to largest. Negative what? -8, very good. All the way to what? 2, very good. So the range is a set of y coordinates. So I'm going to go along the y-axis. See how my ruler's looking? So I'm going along the y-axis, and I test the circle when I'm at what y value? Negative 8. And I stop when I'm at what y value? 2. So my range is bracket negative 8 to 2 bracket. Okay, so that's your range. So no real number outside of that is part of the range. No real number outside of that is part of the domain. All right, now using that idea, you should all now tell me what the range, domain and range of number of letter B is. Okay, good. What else for the range? Oh, not negative 9. It's negative what? Negative 8, right? You can't see it up here. Use your own paper.
Yeah.
So here's negative 9, but this is negative 8. So the domain will be bracket negative 8, comma, all the way to what? 0, right? 0. Now, y'all said something different, and I said, yeah, because I wasn't paying attention. What did y'all say? Negative 9 to what? Negative 1? What did you, okay, so let's talk about that. So someone said negative 9 to negative 1. Is that what someone said?
Yes.
Well, here's negative 9. So first of all, you know that's not correct. And negative 1 is here. Well, you're forgetting about all these x coordinates here. You see that? So it's from this x coordinate. What's this x coordinate? Negative 8 all the way to this x coordinate. You're on the y-axis. So what are the x coordinates on the y-axis? 0, right? Okay. And then what's the range? Go along the y-axis. Negative. Oh, you did the. Because you said negative 9, negative 1. You were doing the range. So negative 9 all the way to what? Negative 1. Okay? All right, now save face. All of you better do number 3 now. Letter C.
Save face.
Oh, not C, I'm sorry, E. Excuse me, that's E. So 3E. Domain, range. All right, let's see what you got. Let's see. What's the domain? Okay, I'll give you that. What's the range? Yeah, same. Because it kind of makes sense that the domain and range have to be the same because where is the center? At the origin. Yes, very good. The center is at the origin. So the domain, you go along the x-axis, negative 7 to positive 7. With brackets, not parentheses now, because these are solutions and they're on the graph, so you got to use brackets. And the range is the same thing. All right. Now, don't make the mistake and say from 7 to negative 7, because when you write in English, you always go from smallest to largest.
The domain is the y-axis and the range is
The domain is a set of x coordinates,
x coordinates and then
and the range is a set of y coordinates. Domain set of x coordinates, and the range set of y coordinates. Okay. So now, let's go back to that worksheet I was showing you. All right, so we're all good with domain and range now. I can do that.